Good day, everyone, and welcome to today's webinar, Accedian+Splunk, providing advanced threat detection, investigation, forensics, and enforcement. Our speakers today are Michael Rezick, Accedian's Vice President for Business Development and Cybersecurity Strategy, Andrei Yazyev, Accedian's Director of Cybersecurity Solutions. And we also have two very special guest star panelists today. We have Tim O'Neill, who's otherwise known as the old comm guy, and Tony Fortunato, who is a Senior Network Performance Specialist and Analyst. And I'll go briefly into a little bit more on each one's bio. Michael Rezick is the head of Accedian's security program, and his experience includes Layer 2 through 7 network technology, cybersecurity, and performance testing. He is also a former professionally licensed engineer in multiple states and is a published author of the Cisco Press book, Building Multi-Service Transport Networks. Andrei Yazyev recently joined Accedian from IBM, where as a security engineer and a threat analytics architect, he worked on the QRadar incident, forensic, and DNS analytics projects. He was also a part of the IBM team that supports collaboration with Quad 9, the secure public DNS service. He is in charge of the product implementation you'll see later in the demo today. Tim O'Neill is an independent network and communications technology consultant. He has over 45 years experience in networking. Tim is also the Chief of Technology and contributing editor for www.networkdatapedia.com, as well as an advisor and regular presenter at Kennesaw State University, the Center for Information Security Education. Tony Fortunato is a Senior Network Performance Specialist and Analyst with experience in design, implementation, and troubleshooting networks since 1989. Tony has been a regular writer for NetworkDatapedia.com for over 12 years.
Thank you, Tom. I wanted to take just a couple of minutes and review the state of the industry. So after decades and billions of dollars, tens of billions of dollars invested in cybersecurity research and innovation, we still see that IT infrastructure and networks are still very vulnerable. The move to cloud has only made these vulnerabilities to attackers and bad actors worse. Over 4,000 breaches reported just this year, and those are only what's reported. And what's really eye-popping is to see hundreds of major breaches against big-name companies. These are organizations, when you look at a BlackRock or a Dow Jones or these large financials, or even the hyperscale companies like a Facebook or a Microsoft, companies that invest literally hundreds of millions of dollars and have armies of security teams to combat these sorts of attacks, and yet they're still getting breached, and that's alarming for sure. As we look at just some other statistics, look at the rise in ransomware becoming very popular. It seems like you can't even go a week anymore without hearing of another major ransomware attack or coordinated attacks against certain entities like public sector or different verticals like that. Obviously, the rise of IoT, it's a wonderful innovation and brings intelligence from sensors and many endpoints, whether it's cameras or light bulbs, automation, everything that comes with it. But it also is a new attack surface, and they're very difficult, if not impossible, to instrument with endpoint agents. So makes network threat detection all the more important. And another kind of eye-popping statistic, at least for me, is the number of companies. 41% have over 1,000 files that are still unprotected, critical files that are unprotected. And so, we're finding the cybersecurity tools are just inadequate to deal with these today, and security teams are getting just inundated with alerts and events and alarms, and what they need are, it's not more ineffective tools. They really need, more time. Security challenges. One of the big topics whenever you engage in cybersecurity research is that of what we call APTs, or advanced persistent threats. The characteristics or attributes of these sorts of threats are, first of all, they're stealthy. It's not like a DDoS attack that's just, oh, boom, up in your face. This is, they're stealthy. They stay below the radar, low and slow, as they like to say. They have huge operational advantages many times. They have teams of people, and they're coordinated, attacks very often across, a number of different folks with skills that are, they use for evil. They obviously leverage and exploit publicly known vulnerabilities. They tend to break in, exfiltrate, and slip out unnoticed, or they stay in and dwell for a long period of time without being noticed. And they avoid auditable events, they avoid error messages, they avoid, they don't create any traffic congestion, and they don't disrupt service. And they use a, custom code, which means that, very often traditional signature methods are not, going to be able to pick up the code, especially for day zero. And the challenge with detecting, APTs is, first of all, rule-based type of detection, 80% of the time produces false positives. And part of that is because, these APTs generally are only, using a strand of an attack one time, 80% of the time. And dwell time, which is the time it takes to detect a breach from the time it enters your environment and your infrastructure, is 190 days. That's 6 months. And that's actually just what's reported. It's actually much longer than that, but that's just what is reported. We've heard of breaches where attackers have been dwelling for years in an environment. And so this is a real challenge. And again, as I mentioned, cloud is another market transition, a big dynamic. Over 60% of corporate IT spend literally is in public cloud applications now. Massive transition. 40% increase in cloud internet traffic. Over 96% of non-Windows devices are poorly protected, and anytime you have an internet link, which is the gateway that 40% of the traffic is entering, and leaving the public cloud, you are exposing yourself 100% to a new attack surface if you're not leveraging something like a VPN or an SD-WAN into the cloud. So. But even then, your exposure within the cloud could also be a challenge, as we've seen with some of the recent attacks. I wanted to just take a minute and look at different categories of cybersecurity technology. These are kind of solutions that are kind of high level, and there are three main categories of cybersecurity infrastructure-based solutions. One is just traditional perimeter protection, and everybody knows this is firewalls or ACLs or security gateways. Keeping the perpetrators, the bad actors, out. It kind of represents this police officer outside of the of this bank scene here. That's kind of traditional perimeter protection. The challenge is people steal credentials. Bad actors can slip in through, other ways. And so perimeter protection is not enough. So endpoint security is another, type of, infrastructure-based security that requires the instrumenting of endpoints, be they laptops, workstations, servers with agents that can monitor that specific endpoint, and they certainly play a role in the overall cybersecurity plan and policy, and that is kind of typified here in this scene as these little agents that are on the ATM machines and on the laptops and so forth. Where Accedian is playing with Skylight and our Skylight security app for Splunk is the network intrusion detection, or what is now kind of being redefined as network traffic analysis category. So this is like the cameras on the wall we're seeing all the traffic, all the movement on the wire. Every attack has to hit the wire, and it leaves a network footprint. And that's really what we're watching. So we're network-based. We're not endpoint-based, and we're not just looking at the perimeter, but we're really looking at, the internal environment, the internal attacks, a rogue employee who launches an attack, or somebody who's exploited internally and an attack is launched internally. We can instrument the cloud. We can basically, anywhere there's a network connection, we can monitor that environment.
The last category of solution or of security technology would be that of what has traditionally been called the IDS or IDS-IPS, intrusion detection, intrusion prevention. It's currently kind of being redefined, and we'll talk a little bit about the redefinition into network traffic analysis. So this is your traditional, what is on the wire? And the idea there is, in complement to monitoring endpoints, you also want, every attack that takes place, has to hit the wire. And so if you're monitoring a few choke points in your enterprise where your traffic, has to traverse, you can pretty much see, on a handful of protocols, the footprint of a cybersecurity attack. And so these are kind of the three major categories. What we're going to talk about today, the Skylight app, for Splunk, is actually this third category. It involves network traffic analysis and looking at network, the network packets and doing security analytics on top of that traffic.
One of the big transitions, as I mentioned, in the renaming of network intrusion detection to network traffic analysis is that there are three kind of signature attributes of this transition to next gen IDS. First is just the ability to really monitor all the way up the stack, so to speak, to the application layer itself, and really looking at application protocols. Traditional IDS looked at up to layers 3 and 4, but now next gen IDS really needs to be able to look at the layer 7 protocols. And the reason for this is that it's really transitioning from just a signature base, which again, it's with attacks like polymorphic malware or APTs like we talked about. Signature is just not adequate, and we have to start to look at behaviors. We have to look at behaviors because they're much more difficult for an attacker to hide. And in order to look at behaviors, you need to see the application layer protocols. You need to see DNS. You need to see SMB and CIFS. You need to see TLS, SSL, HTTPS. You need to see these transactions of all these protocols because that's how you detect certain types of behaviors. So, attribute number 1, transition from layer 2 to 2, 3, 4 to layer 7, moving from just signature to both signature and behavior centric type of detections, and then doing this in real time. This isn't something that you can afford to, with something like a ransomware attack, pull a PCAP file and once a day and see what's going on your network. So to detect all this in real time is a signature hallmark of next-gen IDS or NTA.
So the Skylight-powered threat detection in our app on Splunk, really, it's built from the data up. Our data is very rich metadata that we extract from the wire, and we're looking at layers 2 to 7. We're looking at 100% of the transactions, so we don't sample, we don't top. This is not just another NetFlow with IPFix type of solution. Our sensors require no configuration, so they're very quick, easy to deploy, very rapid time to insight. They report every minute, and they can monitor, especially in the virtual attack surface, over 10 gig line rate. There is no impact in terms of the metadata being transported back to our central data store where we then start to do the analysis. The metadata actually traverses the same production network, so there's no need to outfit the environment with packet brokers or new network links or NIC cards of any special type. We basically just transport a very thin thread of metadata, the little stream back to our data store for that. And what we've basically done is that we've made the packet data, the value of the packet data, very economically viable and operationally feasible to acquire. And that's really a big part of the disruption of our solution. So there's data, there's platform, and there's analytics to any monitoring solution. As far as the platform goes, we're leveraging Splunk. They have both the on-premise version of Splunk and cloud. And it's very open where other integrations. For example, we are integrated with third-party threat feeds that detect malicious domains, malicious IP addresses. So a great way to enrich our context around the detections of events that we see on the wire. And we're also obviously open northbound to feed our alerts and our events into other types of enforcement, tools, orchestrators, or firewall APIs, or even some of our own Skylight our products that can block ports and IP addresses and so forth upon detection of malicious activity. And then lastly, we're leveraging on the analytics, statistical signature, machine learning anomaly type detections, and all these are built in for detecting, investigating, hunting, management of the alerts, and then storing all this, archiving all this forensic for long-term forensics as well. So I mentioned the data. We're built from the data up. Our data is, it's always available because we can cover, every spot now in the enterprise and what I call the digital landscape. There is no more blind spots. It's high definition because we don't sample data. We collect 100% of the transactions, and we collect, across a lot of, the main and crucial application delivery protocols that attackers will exploit. Highly granular, as I mentioned. And again, we're doing all this in a way that's really operationally feasible and economically viable. And one of the biggest challenges when you're doing analytics of any sort, in this case we're talking about security analytics, is really having access to a comprehensive enough data set to reflect the real world. And that's really what we're providing here. As I mentioned, the big message on this slide is, when you think about cloud migration, you have an environment you're monitoring before you migrate. Then you kind of have a hybrid environment while you're migrating, and then post-migration you're going to have a new environment. And the beauty of our solution is it really allows you to, it bridges you from where you are to where you're going, and across the entire journey, or along the entire journey as well of your migration. So rather than having a point product that monitors your on-prem and another product that monitors your cloud, and then something that might monitor during your migration, and what you want to do is really have a solution that could, follow your migration from, beginning to end. And that's really, again, because Skylight has sensors that can be deployed everywhere, virtual attack surfaces, east-west, inside data centers, inside cloud, inside the perimeter. One point economically, we don't charge for our sensors, so we don't charge you to cover your area. And this allows you to really cover your entire digital landscape, and not only in coverage, but also over time. One of the things that, we also are providing is, our sensor provides the threat detection, investigation, forensics, but also a rich application performance monitoring solution as well. So that same sensor and data store infrastructure that you deploy for security threat detection also can drive out application performance monitoring. And again, this is really all part of what we call the Skylight complete visibility. It's no longer do you have to choose between choosing between performance, security. It's all visibility, and we're making visibility available. And so I like to say we're giving you the nutrition of the packets without the extra calories. We're giving you what you need, where you need it, in an economical way.
One thing that's so important today is forensics. you can save your company millions of dollars if after an attack you can prove that you didn't lose X number of PII, PHI, or whatever. And having that metadata, which is the easiest to present to people that, you know, are not network people, it really helps save your company money, and it helps you constantly test to see what your vulnerabilities are. How long is it taking? Where are your attacks coming from? You know, the investigation forensics is so important today. And of course, always performance monitoring. But people today look at the investigation in forensics as, oh, okay. But actually you do it. You give them those tools to go back and go to a judge and say, hey, judge, we have 40 million PII, PHI records, and we had that breach and we stopped it, and we only lost visibility on 4 records. And instead of getting fined millions of dollars, you know, you'll get fined for the ones that you can show them that were lost or that were breached or that were data leaked. So that's important. I just wanted to mention that because people just pass that off today. And there's so many people out there that say they have forensics data. Well, I don't want 6 million frames because it'd take me 4 years to go through it. I want something that I can look at real quick, see what the danger was, see what was lost, or see what wasn't lost. And so that's just, it's very important, and people forget about that all the time.
Well, thanks, Tim. I appreciate that. So the last slide here before we go to our demo. So just a summary of the Skylight advantages. Again, complete visibility, no more blind spots, the extraordinary ease of use, very quick to deploy our sensors and data store. When you download the app, all of the detections are built right into the app. Very easy to implement for that reason. And, you know, again, as I mentioned, you know, we're really lightweight on the storage. We're lightweight on the transport because we don't require any new network infrastructure to be deployed to transport the metadata back to our analytics engine. And light on the CPUs. You know, we're not analyzing full packets, and so the cost of CPU use required to do the analysis and the analytics is low. So really, it's a low total cost of ownership as well. You can go to, you know, we download our app out on the Splunk base page, and you know, with that, we're going to transition over to Andre, and he's going to walk us through a demo.
Thank you, Michael. Hello, everyone. Thank you for being with us today. Here we're looking at our homepage. We call it Incident Poster, where the user can overview what's going on their network right now, what he needs to pay attention to, where those connections are going to or coming from, what the top triggered alerts are, what the time series view of events over the time, over the observation time that we chose. For now, it's 24 hours, and what type of attacks we are dealing with. So I usually prefer to start with most critical alerts and review those first. So for that, we just click on our critical alert count, and next view will present all those alerts and what are they. So here you have a list of all those alerts. If there are too many of them, the list will be paged. In our case, it's just 10, so they all fit in one page. We can see the role name, source, destination IP, what type of alerts, where that alert belong in a kill chain, severity, some rule description, and some management, alert management, like status, was it reviewed before, and the owner, like what kind of user should take care of that. Let's pick one of the alerts and see what we can see there. This will lead us to incident context, where we can review the alert in more detail. So again, we can see all those things that we just saw on the previous page, but also we can see some details regarding what exactly triggered our sensor. And in this case, it's the URI of the URL contained SQL query that suspiciously look like SQL injection. So our analytics detect that and reported that. So what we can do with that next? So let's first assign it to us, since we are looking at that, and set the status in progress and see what else was happening like similar to this alert on the network. Well, there are quite a few of them. So every alert, there is always something that precedes the alert, and we need to review the alert in the context. So since we're talking about web alert, the next logical step is probably to look at the web attack detection center and see what's going on this particular source IP. And this is going to show us on our next page. So here we have a full overview of web attack detection center, for this particular IP address, source IP address. As we can see, there quite a lot was going on this box, but please keep in mind this box is a demo box, and it's intended to be, to have very bad behavior. So we have a bunch of SQL injections, alerts that trigger our sensor 179 in particular. We have also detected possible path traversal attack and possible cross-siting script attack. We have here, we can also overview some statistic of HTTPS protocols, some statistic regarding rare HTTP user agent. We also can monitor every time we see HTTP connection, we scrape the user agent and making a decision on evaluation of how severe the alert is based on that parameter too, because there are few user agents that are known to be malicious, and we want to notify our users about that right away. Here, every cross-site scripting attacks that we detected on this particular box, and and here's a traversal attack. We can obviously see that does look like traversal attack. Someone's trying to exploit a hole in a web server that allows attacker to get an access to system file, operation system file system. Okay, let's go back, and now we can, what else we can see here? We can have a look at HTTP searches, what this box was doing with HTTP searches, or rather what kind of communication was going on in between source IP of our alert, our event, and destination IP. So there's a whole bunch of things going on. We can kind of narrow this down, add in some more filters. For instance, if we're interested in post methods only, we can see all the posts, or for example, status. So all that gives a user a context to what exactly happened, what the user is looking at, and how severe or not severe the alert is. I also would like to show you some other unrelated views that we have in our app, unrelated to this incident. Things like database overview, for instance. Our sensors detecting, parsing not only web protocols, but also all SQL protocols. They can detect how many databases are active on your environment, we can parse all the queries going to those databases, and we do quite a few analytics based on that information. We analyze SQL queries, and we can tell, again, as I saw before, if it looks like SQL injection, or if it's for instance, database exfiltration or database dump. We can do some hunting here to investigate the connection. What was going on this IP address? Oh, that's pretty noisy IP address. It's talking to many things here. So here we can see that. We can see like a kind of breakup of communication between our source IP and others IP. There's a obvious winner in the amount of traffic passing in between these two endpoints, 158, 157, others not that much. We can see that based on timeline and an amount of data, packets going there and back. And here we actually can see raw events that our sensor captured. So I hope that gives you a pretty good overview of our capabilities, what we do here, what we can present, and how that can help you to find something malicious going on in your network.
Okay, thank you, Andre and Michael and the panel. I'm now going to open it up for questions that we've received and direct it to the entire panel so that you can have a vibrant discussion on the questions that have come in. The first of which is which cloud platforms does the product work with?
Yeah, so I'll take that one. So we are able to work on Google, any of the cloud platforms. I mean, we're already part of the marketplace on AWS and Azure, but we install our sensors as an OVA so they can run in Google Cloud or any cloud environment, any kind of virtual environment.
Okay, thank you. Next question is how is this different from other threat detection systems?
Sure. I'll take that one as well. So again, one of the ways in which we're different is some of the threat detection platforms that are out there today. If you look at the historical traditional IDS, again, it was much more heavily signature based. So one of our distinguishing marks is that we're really looking at behaviors. We're looking at how action on the on these various protocols. DNS probing as an example, the ability to look at actual file exfiltration, looking at files, file size, being able to pivot over, giving you the ability as well to not only just give you a detection, but to allow you to investigate, to hunt, to go back in time, and look at events that took place, a day, a week, a month, a year ago, leveraging that data. Another way we're different is the quality of the data itself. As I mentioned, analytics is more than just algorithms. It's the quality of the data. So, one way of getting the data is to try to use something like a NetFlow that's handed to you. But the challenge with that is often it's sampled or it's not available. It's topped, or you got to pay for expensive collectors to actually acquire that. Whereas we're giving our sensors away for you to cover your area. The other way of looking at it is to try to analyze full packets. And again, the challenge of full packet capture, it's very expensive. It's expensive on the storage. It's expensive on the transport. It's expensive on the CPUs to analyze it. So total cost of ownership makes it pretty much economically unfeasible for most organizations to deploy it everywhere for sure, and for many organizations to deploy it at all, as well as the skill set required to analyze full packet capture. So those are some of the ways we're different. So we're eliminating the costs of the sensor. We're eliminating the configuration of the sensor as well. So another easy implementation is really another big differentiator for us.
it's worth noting to add to your point that we're saving probably less than 1% of overall traffic that we see extracting metadata. So that makes, that we still see everything. We know what happened on your network, but we're not spending or, much resources of yours to save that data or analyze that data.
Yeah, that's a great point. Yeah, we're less than 1% of the traffic, and so it's very light metadata. In fact, even what we put into Splunk is very, very light, very lightweight.
Thank you for that answer. Actually, Andre, you answered the next question, which is, I've heard a lot about metadata, and why is that important for security, networking? I mean, what's the big deal? Maybe even Tim, if you want to comment on that and add a few words, please do.
Yeah, metadata is information that people can understand. It's not packets, it's not frames. It's a visualization methodology, which is so essential. When you're engaged in any type of forensics, you have to deal, especially in a courtroom, so you don't want to give them 40 million frames and try to explain it to them. Where metadata really takes that and drills it down to what I call human pictures. So metadata is much more powerful in the forensic sense. And also it's very important because you can communicate with other parts of your company with metadata. You can give it to the people that run the firewall. You can share it with the performance people. So it's much more portable, and my gosh, it's wonderful. You don't have to capture a million frames.
Excellent. Thank you for that answer, Tim.
You want to be somewhere in the middle, right, of every spectrum, and I would say metadata is a middle ground between IPFix or full packet capture. It kind of has advantages of both and eliminate disadvantages of both.
Yeah, it's very important that people start looking at metadata as something that's transportable but has extreme power. There are three elements in any forensics, in network forensics. It's packets and frames, it's metadata, and it's logs. So metadata, as you said, it's the middle ground. But it's so essential that people read it, understand it, and use it.
Excellent. Thank you for that answer. And actually, that answer, Tim, led into actually our final question, which is, how long does the system retain forensic information?
Yeah, so it'll retain it for as long as you want to provide storage. We're leveraging Splunk, and Splunk can store data as it's a big data lake. It can store it forever. Because it is lightweight metadata, you can store, a long-term amount of data in a very, much smaller disk space, obviously, than you can packets. It's probably in the order of magnitude of 1/100th of the disk space required to store a full packet. So, it's really no problem at all to store probably, several years worth of data. I mean, and again, how long, the average time to detect a breach that even reports 190 days, and we know that they're detecting breaches 3 and 4 years later. You probably, for forensics, I'm not sure when you would ever want to flush it out. I'll let Tim, answer that question.
Well, if the neat thing about metadata and the method here is that you can use gigabytes and maybe terabytes as opposed to petabytes and store data for a long, long time. Like I said, the reported length is roughly 190 days before they find the breach. And in most cases, that's too late. They've been able to exfiltrate all your data. So I would say, keep a minimum of like your IRS records in the United States, keep them for 5 years at least. And you can easily do that with metadata.
Excellent. Thank you. That does it for our questions today. Thank you for your time.